So as Cliff mentioned, Model Mania is a contest that we run at SolidWorks World. We've done this since the year 2000, so this is our 17th year of doing Model Mania. If you look at some of the parts that we've done over the years, just get a general understanding. You get 20 minutes, sit down in a booth that we provide a computer in the booth, and we give you a drawing. We ask you to model the part that's on the drawing. You don't have to make drawings, just model the part. When you're done modeling the part, we give you another drawing that is a change to make to that part, and then run a quick simulation. So you can use SolidWorks Simulation or SolidWorks Simulation Express. This just gives you a general understanding of the complexity of the parts. There's really not that many features, you know, and a lot of people can get them done. You get 20 minutes within the 20-minute time limit. So once 20 minutes is up, you're kind of timed out and asked to leave the booth at that point if you haven't finished. So this for 2016, this is our little part. So if you take a look at it, I always say people that are skilled at reading a drawing probably have a little bit of an advantage, because you can take a look at that drawing and very quickly determine how you're going to approach it. In this case here, you know, it starts off with a teardrop shape that's going to be revolved. Got some pockets at the top, another pocket at the bottom, a couple of holes that go in the sides at different areas. So once you're done modeling that, we give you this drawing. So this is the change that needs to be made, and then it describes the simulation that needs to be run on the part as well. So we'll go through these two kind of more in depth. So here's our phase one part, and you can see a lot of times what we'll do for these is to make the drawing very clear. We want to make sure that people aren't trying to interpret the drawing in different ways. So a lot of times we will take off the fillets and the orthographic views just to make sure that it's very clear, and we'll identify that down here. But once we remove the fillets, you can see you got these side pockets at the top, you got a pocket at the bottom, that teardrop shape, which is revolved, and then we define these counterbore holes here for a button head cap screw, and then a tapped hole over on the other side. So this hole goes through one side, the tapped hole goes through the other side. Just a simple 15mm hole at the top. So let's take a look at how we would approach modeling this. So since the question comes up nearly every time I do a webinar, I'm going to get this out of the way early. So you'll see these things pop up on the screen as I go. So if I want to jump into a sketch, I'll jump into a sketch, and you'll see this circular thing around my mouse. All I'm doing is right-clicking, holding down my right button, and moving my mouse around. If I swipe across that, I get to my line. So what is that? That's called mouse gestures, and I'll talk about that in a second. Another thing that we have is what we call the shortcut toolbar. By hitting the S key, you have access to commonly used commands, and this is fully customizable. So let's go ahead and customize it. So here's your shortcuts bar. Under your customization, you can actually make any of these changes that you might want to make. So you can add different things to them if you like to have. Let's go under sketch here, and you like to have your spline command on there. Just drag it on. If you don't like it, drag them off. These are also resizable depending on how you like to organize things. These are separate for sketch, for drawings, for part modeling, assembly modeling, and part drawings, or part modeling. So you can have different shortcut toolbars for each of those, and they're all customizable individually. Now the mouse gestures is this tab over here. I choose to have 8 gestures. You can also just have 4 gestures, you know, in each quadrant if you want. And just to take a look at only the commands that have mouse gestures assigned. Again, as we did before, parts, assemblies, drawing, and sketch can all be defined to have certain mouse gestures that are only in that environment that you're in. So I would encourage everybody to use the shortcut bar, use the mouse gestures. Someone asked in an earlier seminar that I did, which one's more efficient? It's all personal preference. Some people use all gestures, some people use all shortcut bar. I use both, so I don't know that there's any one great answer to that. So you will see as I go through here that I'm using mouse gestures, and you won't be surprised when certain things pop up. So I'm going to start by drawing a line. I'm just going to draw a vertical line up here. Now, still in the line command, if I move my mouse here, I'm drawing a line. But if I come back to that vertex, I will transition into an arc. If I come back to the vertex, go up here, it's a tangent arc, go this way, go that way, come back this way, however I want to do that. But I just want to draw an arc like this. So it's a quick and easy way to stay inside the sketch. I'm still inside the line command, by the way. stay inside the sketch and not have to go choose a different arc tool or whatever to continue sketching. So I'm still inside the line command. I'm picking up tangency off of that arc, go back to that vertex again, and I'm able to create the final tangent arc at the bottom. Let's make these two coincident, and then we'll add some dimensions. So at the bottom here, this is going to be 20, this one's going to be 14, and this dimension between centers is going to be 44. So that's that. Shortcut bar, I have my commonly used, even on my sketch toolbar, I have commonly used feature commands such as the revolve, the extrude, and the extruded cut. So I'll just choose the revolve command. My axis of revolution, you can draw in a center line or you can select any linear entity that you have in your model and go ahead and create your first feature. So there's our first teardrop shape for our model. If you take a look at our drawing again, this is just a PDF of the drawing you'll see pop up. I'll go back and forth. I'm going to put this pocket in at the bottom. Notice this pocket, the depth of the pocket from the bottom is dimensioned from the center of the teardrop, and actually the center of that hole. I don't have the hole defined yet. So what I'm going to do is I'm actually going to turn this sketch on. Let's see if I have my sketches turned off. I do. So I'm going to turn that sketch on. And you can see then I can see my sketch and I can use this vertex and these vertices for dimensioning to. So on the front plane I'm just going to sketch in a rectangle, and this rectangle is just going to be something like this. I'm going to grab that midpoint there, if you will, and just drag it and snap it on there. That establishes my symmetry for my model. We'll add a dimension. I'm going to add a dimension down here and make that 15. And from the center of my arc, which is the center of the arc that I drew previously, up to here, that's going to be 18 millimeters. Fully defined sketch turns black, so I know it's fully defined. And then we'll create an extruded cut. This is going to be through all both directions. And then it cuts my pocket away. Pretty simple, pretty straightforward there. Now the next feature is these little pockets at the top. Now, the way I originally created this model, I drew a rectangle in from this vertex up to there and mirrored it over to the other side and cut everything away. That's one way to approach it. I'm going to show you a different way, and it actually will help me down the road and give you a couple little tips and tricks on the benefits of doing it that way. So let's jump on the front plane here. So I'm on the front plane. That's the center of my model, and I'm going to go ahead and create a sketch. And I'm just going to create a sketch. And I'm just going to create a rectangle. Nothing special here. I'm just going to create a rectangle, something like that. Real big. I don't even need to locate it. I don't need to define it. The only thing I really need to define is from the center to the bottom, and that's going to be 18, again, just as it was at the bottom to create that pocket. Now remember, this sketch is on the front plane, but I don't really want to start cutting from my front plane. And that's okay, because SolidWorks has a really cool tool to help with that. I'm going to change the direction. I'm going to say through all. So again, you can see it's trying to cut through all. I really don't want that, but I want to change my from option here. So I don't want to start extruding from the sketch plane. I want to offset that by 6 millimeters. So what I'm doing is still keeping that sketch and not having to, well, I guess the big benefit here is I don't have to create a plane. I don't have to use reference geometry to create a plane to create that offset plane 6 millimeters. Just saves a step there. And the nice thing about it is I still have access to that dimension, so if I wanted to change that offset dimension, I can do that directly. Okay, so I think everybody knows here we're going to mirror that to the other side. Pretty straightforward there, no problem. On this face, I'm going to create a hole. So it's asking, we have a 15 millimeter through all hole, and then we have these 10 millimeters counterbore for a 10 millimeter button head cap screw, and likewise the tap hole for M10 by 1 thread. So we'll put those on next. So on this face here, I'll create a sketch. Now, I'm going to draw a circle, and you'll see what happens, and then I'll go back and undo some things. So I'm just going to choose that. I'll choose, just size out my hole, and I'll just type in 15. What that's done is it's automatically added the dimension while I'm sketching. So how did that happen? If I just right-click in the graphics area here, you see this little item here, which is Sketch Numeric Input. If I turn that off and draw a a circle and try to type in the value, it doesn't add the dimension automatically. But if I turn it on, it does. So let me take a deeper look at what that is. So in your system options, under your tools options, you go to your sketch, and then you have this enable on-screen numeric input on entity creation. I like to check the second one here because it only creates dimension when a value is entered. So I'll choose both of those. So now if I draw a circle and I don't put in a value, it doesn't add a dimension. If I do, it does add the dimension. So it's just saving me a step of having to add those dimensions while I'm sketching. While I'm sketching that entity, I'm going to key in the precise value. It adds the dimensions for me. So it's kind of nice that way. We'll extrude cut, and we'll go through all except that. So there's that pocket there. Now what we need to do is create those holes at the bottom. For this, we're going to use the hole wizard. Hope everybody's familiar with the hole wizard. It's I like to think of it as my machinery's handbook. All the information that sizes the holes, what the size is, what the proper size for a clearance hole for a 1/4-20 socket head cap screw, or an M10 button head cap screw. I don't have to look any of that stuff up or go to my slide chart or whatever. So here we have an ANSI metric. I want a button head cap screw. This is going to be M10, and I want that to go up to next because I only want to go through one side. I'm going to need to place this onto this spherical face here. So you don't always have to place your hole wizard holes onto a planar face. You can place them onto a non-planar face as well. And to simply do that, you can choose the 3D sketch button, or I'm just going to click this face here, and it automatically knows that now I'm placing this onto a non-planar face, and then I'll place my hole right there. So that's pretty simple. If I look at the relation that exists for this, it is an on-surface relation. It knows that that is on the surface. The other interesting thing about placing using hole wizard on non-planar faces, instead of creating the first location sketch as a 2D sketch, it creates it as a 3D sketch. So now I'm in the 3D sketch environment and using the 3D sketch relation tools as well. So here's my x-axis, and here's the center of my arc there. So I'm just going to make these along x. So I'm adding that. That's a relation that is available inside of the 3D sketch environment. So I'm aligning those along the x-axis. You can see my point turns black. That means it's fully defined. If I hit the D key, actually I'll undo that. Notice we have the confirmation corner. I can hit OK to get out of my sketch and finish my command. But sometimes I don't like to move my mouse all the way up there. So hitting the D key brings the confirmation corner to your mouse. So I can hit OK or hit cancel at this point without having to move my mouse all around. So that's a kind of an interesting little accelerator, little tool that helps you be a little bit more productive and keep your mouse movement down. On the inside here, we're going to create another hole wizard hole, and this one is going to be a tapped hole. ANSI metric, a tapped hole, and this is going to be M10 by 1. M10 by 1, up to next is fine. We'll use the positioning. I'm going to place it on a planar face and just place it right there. Here I'm going to line these two up and just give a coincident relationship for those two. So that lines up properly. Hit the D key and we'll hit OK. So there's kind of the geometry that we have without the fillets on. Then the last thing we want to do is we want to add these fillets. So you can see these fillets wrap all the way around, all the way around, and all the way around that. So let's go ahead and add our fillets. It's going to be a 2mm fillet. I'm going to choose just these faces here, and notice that it's wrapping that around because it's grabbing all the edges associated with that face, but any tangency as well. If I choose this, it's going to give me a fillet around that circle or that hole there, and I don't want that, so I'm going to unselect that. And then finally down here we'll choose this face as well, and you can see it added all the fillets properly. Now this isn't necessary, but especially for Model Mania, I like to add a little color to these because it helps me visualize and visually see, hey, do I have all of my fillets accounted for? Did I get all the edges that were prescribed on the drawing to be filleted? Then the last thing we need to do is add plain carbon steel. So on your right click, you have all your favorites listed here. For if you ever go to Solidworks World and sit down and try the Model Mania challenge, a little tip here is that I always put the material on your favorites so you don't have to go into edit material. If at home you're trying to you want to have your own favorites on there, just go into Edit Material. Here you have your lists of all your materials that are available. Choose one like this and right-click on it and say Add to Favorites. If you click Add to Favorites, it's already on the favorites list, okay. You have this tab over here has all your favorites that are already there. So if you have certain materials that you use quite often and you don't want to go in and come into this dialog box very often, add them to your favorites, and then they're right there on your right click to add your material. So that's the phase 1 portion of Model Mania 2016. Got our part all done. So once you're done with that, we give you another drawing. The other drawing says, here's some changes that we're going to make to that. So here's the changes that we're going to make. And typically on this drawing, we're only going to put the dimensions that are changed, with the exception of maybe some reference dimensions that might be required. But you can see what we're doing here. If you look at this cross-section up here, this quarter section, we're actually putting a spherical dome, or if you will. Instead of that ceiling being planar, that's now going to be spherical. So it's 22 millimeter spherical. You can see it is spherical, obviously, in this view and this view as well. So you can see how that goes in. The other thing we got is this 2x20, which is a cylindrical surface. So imagine you had a rod end going in here, and it's spherical, and you need it to be able to have some clearance in there. You don't want to have that planar surface anymore. So that's that. Here's the simulation. We'll come back and talk about that once I get the modeling done. So how are we going to approach this? This face needs to go away, and it needs to become cylindrical. This face needs to go away, and needs to become spherical. So first one first, let's take the easy one. This one's going to be easy. Because of the way I define this, it's actually fairly simple. So I'm going to come in here, and I'm actually going to do this the wrong way because I want to show you a little capability that we have. So if I take this here and I say, okay, I want to put that 20 millimeter arc on there. Let's just draw in a center point arc from the center, from here out to there. That's my arc. And I'm going to delete this line. Some people on the phone are saying, no, Mark, don't delete that line. That's not the right way to do it. You're right. That isn't the right way to do it. But I'm going to do it the wrong way in case some people aren't familiar with this. So I deleted the line. I put R20 on there. I don't really worry about any of those up there, and I hit exit. So what happens? My fillet fails. Well, that's because I replaced that line with an arc, and it didn't know to swap those out. So I'm going to use the undo command and come all the way back here to my sketch delete. So here I am at sketch delete. I'm going to delete this dimension, and we'll put on the 20 millimeter dimension, something like that. So the better way to approach this is to use the replace entity. So I can choose this guy right here, and I can say I want to use replace entity. Replace entity, replace this entity with this one, and I can either choose to delete that entity or make it construction. We'll leave it construction for now. So I want to replace it with this one. So what I'm doing is I'm telling SolidWorks, redefine whatever was associated with that edge to now be to that with that line, whatever that created, a planar face, to now assign it to this one, and now it's going to take care of that for me. So you can see it made that construction. This is now an arc or a cylindrical face, so when I exit out of my sketch, my fillets don't fail because the face identifier or the face ID for this particular face was reassigned, and SolidWorks took care of working out the fillets for me. Not going to be that easy for this spherical face down here. So the way I define this from our previous sketch here is a rectangular cut. Went through my model. I could try to go in here and change it, delete it as an extrude, try to change it to a revolve. I can do all kinds of things like that. It gets a little bit more involved. So I'm just going to roll back before that fillet there, and I'm going to define a spherical surface. So instead of a solid entity, I'm going to define a spherical surface. So we'll just sketch in, let's sketch in a center point arc from here to here, something like that. It's going to be 22 millimeters. And we'll put in a center line, and we'll revolve that as a surface. So that's now a surface that I've placed into my model to replace with a face. The Replace Face feature on your Surfaces Command Manager tab is the tool that we want to use. I'm going to replace a solid surface with a surface from with a face from the surface that I just created. So I want to replace this with this. and I'll hit, oops, I'm going to place this with this. So I'm replacing one with a different surface, and you'll see what happens. So it actually replaced that. I could hide this, or I could just hit the Tab key. Tab key works now in part mode, very similar to the way it works in assemblies. You can hide a part in assemblies. Well, now you can hide bodies, surface or solid bodies, inside of part mode. So you can see I used the replace face to actually redefine that face to now be spherical. When I rebuild, okay, my fillet, I changed the face. The face IDs don't match back up when I do it that way, but I can easily redefine that. You can see it's got a missing face. I could delete that, but I tend to be kind of lazy. I'll just hit enter and let SolidWorks remove that for me. So you can see it did a nice job there. You can cut a cross section of this guy here. And like if you just did a standard planar cross section, a 2-section cross section right, you can see that I now have that. Or if I use the zonal option up here, it allows me to just make that quarter cut section, which is kind of nice. You can see I now have my cylindrical face here and my spherical face on the bottom. That works out pretty well. So once we get that done, we ask you to run simulation. So we're asking you to hold these cylindrical face, these two cylindrical faces, and then apply a 5,000 Newton load in the vertical direction. So let's jump over here. And I could use SolidWorks Simulation. I'll actually use SolidWorks Simulation Express because a lot of people aren't familiar with it. I just want to show you just how easy simulation can be. So the first thing it does is it takes you through this wizard. Gives you a little bit of introduction. You can read through that. Hit the next arrow there, and you can see I got fixtures to define. I got loads, materials already defined, and then we'll hit the run and view our results. So let's add a fixture. I want to hold this and this. Okay. Now we're going to say next. I'm going to add a force. You can see it added the nice little icons there. Let me know that that's fixed. I'm going to add a force to this face, but I don't want it to be normal to the face. I want it to be in a selected direction. That direction is going to be to the top. I want 5,000 newtons. So there's my load. You can see that's on there. Materials already defined, so we'll hit next. I could change it at this point. Finally, the next thing I want to do is just run my simulation. That's it. So first thing SolidWorks does on the results is it says, hey, is it behaving as you would expect it to? Yeah, this you can see it's doing a little animation, obviously exaggerated, but an animation of the deflection that would take place. And yes, it is behaving as I would expect it. Do I want to see my stress information? So there's my stress information that I have for my part with the values listed. I can also look at displacements. How much is this thing actually moving? Very small because it's a pretty beefy part. Or I want to see my factor of safety. My factor of safety is about 5.1 for this part. And if I just say only show me factor or highlight the factors of safety below 10, so you can see these are all the ones that are below 10. 10 is a pretty high factor of safety. 5 is actually a pretty high factor of safety. So we're within our within our limits. But this is the number that we want you to report. So obviously to get the best results for this, you have to have an accurate part, you have to get your factor of safety right, and then we judge it on time. So that's the Model Mania for 2016. One of the things I wanted to kind of give a shout out to is all of our winners. So we separate the customers from the resellers. So customers compete against customers, resellers against resellers. And these are our winners for this year. Sometimes you can see the times, best times were, around 13 minutes here and 12 minutes here. Sometimes our customers are faster than our resellers, and that's because they're good and they use the stuff. They're in SolidWorks probably 8 hours a day. They're building lots of complex, nasty parts. So I always like it when I see our customers are faster than our resellers. But we got some hot shots on both sides of the table there.